In this problem, I'm going to talk about how to calculate average velocities using the average velocity equation. So I'm going to have a simple example here, and basically it's going to be a car that's going to travel along a road, and it's going to do it in two parts. The first part is going to be 40 kilometers, and you'll notice here I'm going to put around the kilometers, km. I'm going to put brackets. Brackets always denote units in physics class. And the second part's also going to be 40 kilometers. So I'm going to say x2 is 40 kilometers. The first part, the average velocity, it's going to travel to velocity. It's going to travel to average velocity of 30 kilometers per hour. And the second part is going to speed up and go a little faster, twice as fast actually. It's going to go 60 kilometers per hour. And what we need to find are a couple things. We're going to find the average velocity for the entire trip. So I'm going to say A, find V bar, just the average velocity for the entire trip, no subscript. And then B, we want to plot its position versus time. We'll plot that. So when we do quantitative type problems, there's a set way of doing it. For the kinematic problems, we have list equations, list the variables, and solve. So for the equation for this one, average velocity, we use the average velocity equation, which is delta x over delta t, how far I traveled and how long I took to do it, okay? And we're simply writing the equation down. As we get more into the problems, there'll be 2, 3, 4, 5, 6 equations that are applicable to the problem. We list them. Step 2 is we list the variables. So we say v bar, delta x, and delta t. And here we are trying to list what we know and what we don't know. So here in this part, list variables, average velocity, I don't know it. I'm trying to find that. So I put a box here to clearly show that I don't know that. For the entire trip, I actually do know how far I traveled. It's 40 kilometers for both parts, so a total of 80 kilometers. So I do know that. Brackets. And the time traveled, I don't know. I do not know the time it took for the entire trip to occur. However, they give me this velocity information, which I can probably use to get the time, but right now I don't know it. So, solve. V bar is equal to delta x over delta t. So I know it's 80 on top, but I don't know the time it took. I don't know that number. So we're actually going to do a little side calculation, and from time to time you're going to have to do a little side calculation to figure some things out. So I'll put side calc. And really what we're going to do is we're going to use this velocity equation to find the time. So for each part of the trip, if I know how far I've traveled and my velocity, I can actually find the time. So for the first part of the trip, right over here, if I solve for delta t by cross multiplying, I have delta x over velocity, which is 40 over 30, which is, according to my calculations, about 1.33. The units are hours, since we were dealing with hours. And for the second part of the trip, delta t is equal to delta x over v, which is 40 kilometers, but 60 kilometers per hour, which according to my calculations is 0.667 hours. Okay, so now we know the times for both parts of the trip. And given to round off error, I think that's probably about 2, so I'm just going to put 2 here for 2 hours. So our final answer here is 40 kilometers per hour. And then we box our answer. All right. So when you first looked at this, you might have thought it was 45 because half of 30, half the difference is 15. So put it right at 45. However, that's not true because even though the distances are the same, the times are not. Because we're going slower here, we're more in this region time-wise than we are in this region. You can see the difference here. So this is weighted, if you want to use weighted as a term, it's weighted more heavily than this section over here. So we have 40 kilometers per hour. That was part A. So make sure that's part A. Part B I'll do up here. On your homework you'd have some space below in graph paper, so you can do it in your graph paper notebook, homework notebook, but I'll do it right here. Okay, and so I'm going to draw a little graph, and this will be position versus time. And let's see, for our problem here, we're going to go out to about 2 hours. So I'll say this is 2 hours here, 1 hour is right there in the middle, and then 40 kilometers here, and 80 up there. These are kilometers, label axes. This is hours. Okay, so it takes me 1 1/3 hours to go the first 40 kilometers. So that's about a half, third's about right here, I'll say. So during that time frame, I travel 40 kilometers, 1.33, right about here. And the second part of the trip, 2 hours up here, bring that over to 80 and so forth. I have a little bit higher slope. So you can see here that the slope has something to do with my average velocity. And if you look at the axes here, it's just rise over run. This is the rise over the run. Delta x right here is basically, if I use some dotted lines here, this is delta x. And this right here is the base of the triangle, delta t. So the rise over the run is actually the slope. You can see here I have a higher slope because I was going faster. In fact, the slope should be twice because it's twice as fast. And then I could actually draw a line down here from the beginning point or the end point all the way to the beginning point, connecting these 2 points. And that would be the average velocity for the entire trip, or a slope of 40 kilometers per hour, which is what my answer was for the problem. So there's a graphical representation of the motion for this car. So in any given quantitative problem, there's the given section, in which case you're trying to draw a picture of the problem so we can see where everything is located, where the velocities are, times are, and so forth. Find, clearly state what we need to find. And we have 3 parts to our solution. We have list equations. In this case, there's only one. When we get to the kinematics model, you'll see that there's 3 in the next video. We list the variables. If we know it, we write it. If we don't know it, we put a box. Okay, and then we solve. And in this solve part, we had to do a little side calculation to find some times. And after we found those times, we plugged it back into our equation and found our final answer. We box our answer. And in your homework, if this were problem number 1, let's say, you would highlight the number. And that helps me to find your homework problems in your homework notebook. So there is an example of a quantitative style type homework problem with average velocity.